Hello everyone, today's topic is L systems. So usually L system allows the definition of complex shapes through the use of iterations. So initially L systems were used to draw trees or any complex diagrams. L systems usually what we do is we initially declare variables, for example f, and then constants plus and minus. Over here f means moving forward, plus means turning 90 degrees towards the right, minus means turning to the left by 90 degrees, and axiom means the initial a rule. Here we're just going to give forward, and then over here I'm going to give rules f plus f, which means that every time there's an f it should be replaced by f plus f with each and every iteration. For example, when you have f over here, it just means forward, but when I go to the next iteration it becomes f plus f, which means that forward and then turn right and then move forward. So it gives this shape. Now if I again go to iteration 2, it becomes f plus f, the constant remains the same, and then again f plus f. This becomes first move forward, then turn right and then move forward, and then again turn right, which is towards this direction, and then move forward, and then again turn right and move forward. So what we have done is that we have gotten a square over here. So this is how we define various iteration rules, and we can find out the L systems. So now I'll be showing the code for a L system using C. As you can see over here, I've actually used this code to draw circles. I'll explain you first what the code does. So basically what the code does is that first it draws a circle with a center, and then I'll be moving halfway through the distance and drawing another circle like this, which passes through the center to the right, and then again to the left also I'll be doing the same thing. So this thing keeps on going, and you will be noticing circles going on like this, you know. So if the circle is too big, then you'll be noticing circles like this. If the circle is too big, it would basically come what we have drawn over here only. So I'll just show the code. So I have used the function draw circle. I have used the parameters x and y, which is the center and the radius. So I've drawn the circle. First I've drawn the circle x comma y comma radius. Then I've checked if the radius is greater than 2. Then I'm moving to the right and I'm drawing the circle with half the radius, and then I'm moving left and I'm drawing the circle with radius r by 2, but half the radius. So in the main function, I've first initialized the graphics window, and then I've called this recursive function. So the output comes like this. So as I told, you can notice just a big circle. We're not able to see it completely, and then inside we're able to see two smaller circles, and recursively inside these kind of circles have been made. So this is one example of L systems. So the main problem in DAVE C++ is that it doesn't have turtles library. So to make it more complex, or to draw more different diagrams, you can use Python. For example, you can see over here I've written a Python code. So this Python code, I'm using the directory turtle. So over here what I'm basically going to do, I'm going to first explain it. So in the code what I've drawn, I'm first initializing the variables f, and the constants will be plus, minus, and there are two brackets. But in this code we won't be using the brackets, it will be a very simple one. And the rules will be, I'll explain how to go to the rules. So first what we'll be doing is that we'll be assuming first one straight line, because that's the axiom. And then if we want to draw this, so this will be 90 degrees. So first we'll be moving forward and then turning towards the left, and then again moving forward and then moving towards the right, moving forward, turning towards the left, turning towards the right, moving forward and then turning towards the left. So with this we can understand, first move forward, let us assume that turning towards left is positive, so plus f, then again turning towards the right it becomes minus, and then again moving forward f, and then moving towards the right which becomes minus, then f, and then we are turning towards the left, so again it becomes plus, and then again moving forward, so we get f. So this is the next step. So the rule becomes f plus f minus f minus f plus f. So now what happens is that in the next iteration this becomes 1f, so this one again becomes a small thing and it will be replaced by this. So even this line which is there is replaced like that. So using these different things, these iterations, you will get this kind of diagram. So this thing keeps repeating and you can use how many ever iterations you want, and you will be able to obtain the final desired complex diagram that you want. So now I'll show you the code. So you can see over here, first I've imported turtle, I've defined the angle D to be 90 degrees and the length of each forward to be 10 units. So then I've defined an function iterate which contains the axiom and the initiator which is the f. So then I have used translate. Translate is basically the function which I'll be using to find, using the iterations, I'll be finding the final result, the string that I want. So I have declared the variables and the constants, the constants over here, plus minus. So for each translate, that the current which we're having, we'll be working on that and the axiom to actually get the string. So what we'll be doing is that we'll be first checking each character in the string, and then if it is constant we'll be keeping it as a constant, but if it is f, then we will be using the final axiom what is there and we will be replacing it in the result. So what I mean by the axiom over here is rule. It is not the initial one which we are using. I'm repeating once again, the axiom over here is basically the rule. Okay, so result plus or equal to axiom, and then I'll be returning the result. So this is the function inside iterate. The main code inside iterate is, first we'll be initializing result to be initiator, that is f, and then what I'll be doing is that I'll be considering the range from 0 to num. Num is basically the number of iterations that I want. So I'll be calling the function translate those many number of times so that I'll be getting the final axiom. So then I'll be returning the result. Now using this result, I'll be drawing the final image. So for this, I'll be using the turtle library. So what I've done is that first I've called the turtle, using the turtle library, I've got the screen. This will display the graphic screen that we want, and we have defined a turtle, a basic function to draw the thing. So to make it more simple, I have hidden the turtle using the hide turtle function, and to make it fast, I have increased the speed to maximum, And then I decrease the speed so that you can understand how it is drawing. And then I have first in actually when you have the turtle, it will be actually pointing towards up. So to first I'm making it point towards the left, and then we're going to start drawing the axiom. So for basically for the computer to understand which symbol defines what, uh, I have used each character in the axiom, and then I am telling if it is F, then move forward by distance L. If it is plus, then move left by a degree 90 degrees, that is degree D. If it is minus, then move right. And then if it is a bracket, then we'll be using stack to understand what is to be done. So if it is like that, then we'll be pushing. If it is a closed bracket, then we'll be popping, and then we will be uh, actually using pen up. We will be skipping. Like what we're doing is that instead of drawing, we're just moving the turtle from one position to another position. For that, we'll be using go to, and then we'll be using pen down. So finally, we'll be able to draw. So when we any click any of the cue, then we're gonna close the screen. So this is the main thing that we'll be using. So now inside the main function, I have declared the first axiom. Um, so I'll make this axiom as, sorry, F, and then I'm using, let me make it 5 iterations. And then after the axiom is called, we had first we're using we're finding out the string using the iterate function, and then we are drawing the final uh, I'm like the string that we're gonna get. So when I run this module, okay, first I need to save it. Just a second. Running the module. So this is the initial thing that you're gonna get. I know it's very small. Just a second. I'll increase the number of iterations. So let's increase the number of iterations to 4. You can see over here. This is how the final output looks. It's gonna end over here. So this is the code for L systems. Thank you.